Number 7. Is it because it's not on the unit circle?
Yeah.
I'll put it on the unit circle. I'm going to blow your mind. You ready for it to be blown? Watch this. Oh, I feel the anticipation just building. Is that on the unit circle now? Negative square root of 2? Yes. We have to simplify the denominator. All right? And for all those times you were in a math class and you're like, why do we always have to get rid of the radical on the bottom? It's for this exact reason. So we have a standard thing that I put it to, and then I can go to a standard thing on the unit circle. That all mathematicians know that this is the same. So we're not trying to constantly in our head convert numbers back and forth. Good? Cool. Other questions? That was a good question. The other class didn't ask that. But when I brought it up, they didn't know the answer. But I was like that when no one has a question. I'm like, well, how'd you find this one? No other questions are good? How was it? Was it okay? Were inverses okay? All right, make sure you get them down. Make sure you get them down because you know for a fact on the test you're going to have a section that looks just like this, bigger, that you're going to fill in the values. And I'm not expecting it to take 18 hours for you to read the unit circle backwards. All right, just like the one on the test. That was 20 points. 20 out of 100 points was just that one little block. That was on the test that just asked for the sine of pi over 2, sine of 3 pi over 4. All right, so it's a big portion of the test is just knowing these values. All right, if there's no other questions on that, then let's go ahead and get into today's lesson. Today's lesson is going to be on your inverse of your cosecant, inverse of your secant, tangent, and inverse of cotangent. So there's a lot of information coming at you. We're going to develop the graphs of these two. I am less concerned about cosecant inverse and secant inverse than any of the other ones. So you can almost guarantee neither of these two graphs are going to be on the test. Everything else is kind of fair game. But these two are just kind of these oddball-ish kind of thing. All right. But if it did happen to be on the test and you did not study it, you could come up with the graph on your own. Because we know that cosecant has something to do with sine. They're reciprocals. So in order to come up with our cosecant graph, we'd first draw our sine graph. Our sine graph starts at 0, 0, and goes up here, goes here, goes here. Ooh, I should do a light color. I'm going to do a light color. I'm going to do light blue. Like a groovy blue. Be cool if I just had a rainbow. Wish they had a rainbow one. So I'm going real light because it's not my actual graph. It's just to help guide me on my graph. I'm also going to go back just a little bit. I'm going to add this little section on here. Because you remember when we did the sine inverse, we took this section here. We took this section here, so we had to go back a little bit. So we're going to do the same thing for cosecant. Now to actually graph our cosecant, we'd put vertical asymptotes wherever sine is 0. So this is good practice at graphing our cosecant functions. And then all we have to do is just go up instead of down. Just a reminder that if you did not do so well on that quiz, you can always retake it. I'm also going to do the one over here. All right, I know it doesn't really fit, but we're going to do that. All right, we're going to note, once again, this does not pass the horizontal line test. In fact, even if I just took this one U shape, it still wouldn't pass the horizontal line test, so it's not invertible. So what I'm going to do is I'm going to take half of U on the bottom, and I'm going to take the other half of U up here. In other words, I'm going to draw a box. Let's use brown. We're just going to take this part of our cosecant graph. Because if we picture everything else fading away, it would pass the horizontal line test. That means my cosecant inverse function exists in quadrant 4 and quadrant 1. Those are the only two places it exists, is quadrant 4 and quadrant 1. So this stuff kind of fades away. And so our cosecant exists right here. Well, that's nice because that's where sine inverse existed. So if I know where sine inverse is, I know where cosecant inverse is, which is nice because the reciprocals, they always are hand in hand with each other. So it's nice that once I know sine inverse, I know cosecant inverse. Now the graph of this, to graph these, all you have to do is look where your vertical asymptote is. My vertical asymptote's at 0. So if my x and y values switch between inverses and the regular function, this vertical asymptote will now be a horizontal asymptote right across the x-axis instead of the y. Then I'm going to note this point up here is pi over 2, 1. That point right there is pi over 2, 1. This point right down here is negative pi over 2, negative 1. The reciprocal, I just flipped my x and y values. So instead of plotting pi over 2, 1, I'm going to plot 1 pi over 2. And these lines get close to the horizontal asymptote, so this is going to go like that. It's going to go like that. And if you plotted our other point, you'd plot it at negative 1, negative pi over 2, and it would look like that. And this is our cosecant inverse graph. A lot of information here, because definitely on the test you should be able to graph this. Definitely, just the cosecant. Don't worry so much about this, but you should at least be able to graph all of this. All right, like I said, our cosecant, which is noted as cosecant inverse or arc cosecant, remember these two terms are the exact same. If one confuses you, just change every time you see arc cosine to cosine inverse and work from there. Well, that exists in quadrant 1 and 4. All right, here's where it gets tricky. Here's where it gets tricky. When we did cosecant, so if I asked for the cosecant of pi over 6, I actually found 1 over sine of pi over 6 because they were reciprocals. With inverses, it's going to be different. The example isn't the greatest unless you can picture it. So cosecant of pi over 6 equals 1/2. The sine of pi over 6 actually equals 2. What that means is the sine inverse of 2 is pi over 6, and the cosecant inverse of 1 over 2 is pi over 6. That means cosecant inverse of 1/2 is the exact same as sine inverse of 2. You don't have to memorize that, but I do want to note the fact that sine inverse would actually be 1 over 1 over 2. That's another way to rewrite 2. If all that seems really confusing, you're not sure what's going on, just make sure you get the next statement down. Cosecant inverse of x is going to equal the sine inverse of 1 over x. So whenever I'm looking for cosecant inverse, I'm going to take the sine inverse of that 1 over whatever that value is. I'm going to put a little note over here, a note that we don't get confused. So I want to think about this every single time. Note that cosecant of x equals 1 over sine x. Do not forget that this is true. All right, cosecant of an angle equals 1 over sine of that angle. Cosecant inverse of a number is going to equal sine inverse of 1 over that number. Keep that straight. So ask yourself, am I doing an inverse or I'm just doing the sine function? All right, because it makes a big difference. So always think of that either time. So don't forget about one or the other. All right, so we're supposed to do cosecant of negative, or cosecant inverse of square root of 2. Well, I'm going to rewrite that as sine inverse of 1 over square root of 2. I'm going to note that 1 over square root of 2 is not on my unit circle. Well, it is. It's just not in the correct form. So I'm going to simplify the denominator by multiplying the top and bottom by square root of 2, which is actually going to equal sine inverse of square root of 2 over 2. I'm going to quickly write in what I just did. And the reason why I do that, and I would do it on my notes too, is sometimes when you study this like a month from now or something for a test and you're looking back and you're like, how did I convert that? Sometimes it's just nice to have those little notes of what you did. Alright, so now all I have to do is go to my unit circle, find out where my sine is square root of 2 over 2. Do I have a unit circle back here somewhere? So I have it in two places. I have it at pi over 4, and my sine is also at 3 pi over 4 is square root of 2 over 2. So let me highlight my two options. I got square root of 2 over 2 here. I got square root of 2 over 2 here. So my answer is pi over 4 and 3 pi over 4, correct?
No.
I'm glad one person was angered by that. It can only be one answer, correct?
Yeah.
What answer is it going to be if I'm sine or cosecant? It's going to be the pi over 4 because it's in quadrant 1. Yep, so our answer is going to be pi over 4. Arc cosecant of 1. Remember, arc cosecant is the same thing as cosecant inverse. So I'm just going to rewrite this as arc sine of, technically it's 1 over 1. But we just know 1 over 1 is just 1. So I'm looking for where my sine value is equal to 1. My sine value is only equal to 1 in one place. So I don't even have to decide what quadrant it is. The only place it's equal to 1 is at pi over 2. So that's going to be pi over 2. Alright, the hardest part about this is remembering this and not getting these two things confused. Alright, and it's going to happen. I guarantee you several of you will make this mistake. You'll use this one whenever it was an inverse, or use this one when it's not an inverse. You just got to think every single time, which one am I using? Alright, secant. Pretty much the same lines as our cosecant graph. We're just going to graph cosine this time. So my cosine graph starts at 1, comes down to 0, goes down to -1, back up to 0, back up to 1. And then we just have to draw vertical asymptotes wherever our cosine was equal to 0. And wherever it was going up, it's going to go down. Wherever it was going down, it's going to go up. If you remember when we took the cosine inverse, we lopped it right off at pi and 0. We said, I just want this little squiggly mark. Well, if I cut it in the exact same place for our secant, it is also going to give me an invertible function. So in fact, we're going to cut it off at the exact same point as we did with our cosine inverse. We're going to start right at 0, cut that guy right through, all the way to pi, and we have those two little sections. So just like cosine inverse, our secant inverse will exist in quadrants 1 and 2. And 3 and 4 do not exist. We're going to graph this the same way we did the other one. I'm going to look at where my vertical asymptote is. That is at pi over 2. So we're going to go to pi over 2 here and draw a horizontal asymptote. I'm going to note this point right up here is 0, 1. So we're going to find the point 1, 0. 1, 0 is right here. and we're going to go up towards the asymptote. My other point is at pi -1, so we'll have -1 pi. Yeah?
Why do you do the vertical asymptote horizontal in the other graph?
Oh, compared to this one?
Yeah, like why do you change it?
If you remember from inverses, we switch our x and y values. So what that honestly does is it takes this and flips it, just like this. Everything that's on this graph gets flipped kind of like this. It gets reflected across the line x equals, or y equals x. All right, it's just the way it happens when you change your x and y values. Okay? Our other point, what did I say, was at pi -1. So a -1 pi is up here. So Juan, you can check this too. You can grab given points from a vertical asymptote and plot them over here, changing your x and y values, and it will be on this line. All right, so if you ever want to test that, just pick a point, and you'll see it works perfectly. It is the switching of the x and y. I'm not just making anything up, it's just I'm honestly switching the x and y values. That's what an inverse is, switching the x and y values. Is that satisfied, or are you still like, I still don't get it? All right, this is going to be my secant inverse. All right, we said that it's going to be in quadrants 1 and 2. We're in quadrants 1 and 2. All right, so secant inverse of x is going to be the exact same thing as cosine inverse of 1 over x. But to keep myself sane, I'm going to make a little note to myself that anytime I see this, I'm going to check to make sure it's the inverse. Because if it's not the inverse, if I'm just looking for the cosecant, or not the cosecant, the secant of x, then it would just be 1 over cosine x. So you look for the inverse. That's the only time you put it on the inside. If it's not the inverse, then the 1 goes on the outside. It's 1 over. All right, so I'm supposed to find the secant inverse of -2. That means I'm really looking for the cosine inverse of 1 over 2, negative style. I just got to go to my unit circle, figure out where cosine equals -1/2. It equals -1/2 at 2 pi over 3. And it also equals it at 4 pi over 3. 4 pi over 3 is not a solution because that's in quadrant 3. We're going to take the quadrant 2 one, so it's going to be 2 pi over 3. Arc secant of 2 is the same thing as arc cosine of 1 over 2. So I'm just checking where cosine is 1/2. Cosine is 1/2 at pi over 3. So our answer is going to be pi over 3. Any questions on how I got either one of those two values? You should probably have your unit circle out just so you can be checking along with me in case I make a mistake, or you can get ahead of me if you just know what you're doing. But you shouldn't just be trusting, yeah, he must be right, he's teaching it. All right, because you've got to constantly checking to see if you understand where these numbers are coming from. All right, inverse of a tangent function. Inverse of a tangent function. If I had a graph tangent, I'd put a vertical asymptote at negative pi over 2, and I'd put one at pi over 2. And our tangent value goes up. So from left to right, it goes up. Just for the sake of this, we do know that the tangent value keeps repeating itself over and over and over. And that's what makes it invertible, is the fact that these will repeat over and over and over again. That's what makes it invertible. Well, tangent's nice because it just makes sense what we're going to do. We're going to say if repeating it makes it non-invertible, how about we just don't repeat it and we just stick with the one cycle. And that's exactly what we're going to do. We're just going to stick with one cycle. All right, we'll stick with one cycle. I think I was using brown. We'll stick with one cycle. And that's going to be quadrant 4 and quadrant 1. So we're going to use quadrant 4 and quadrant 1 for tangent inverse. So tan inverse. I'm also going to write it down below because we know that's going to happen. I wrote it on every one of them. 1 and 4. Cool. So it shares the same quadrants as cosecant and sine. Quadrant 1 and quadrant 4. Graphing this, it's pretty easy. As long as we agree that vertical asymptotes turn to horizontal asymptotes. So we have vertical asymptotes at negative pi over 2 and pi over 2. So we're going to put a horizontal asymptote at pi over 2 and negative pi over 2. Now if we picture, when I take the inverse of something, it flips it like this. All right? So it takes this and flips it like that. So tan inverse is actually still going to be going up. So that's kind of how I remember it. So I'm not doing this weird hand motion on the test. I just know that because tangent's going up, tangent inverse will also go up. Which, thinking ahead, cotangent goes down. So cotangent inverse will also go down, but it'll be on its side. So notice our tangent's on its side. All right, that's tan inverse. We're in quadrants 1 and 4. Now, tan inverse of square root of 3, this is where it's nice to have all our tangent values on our unit circle, because otherwise I'm trying to develop them. So you should have them written on your sheet. If not, I got them up here. All right, get them on your sheet, get them memorized. It'll make your life so much easier. So I'm looking for the tangent inverse of square root of 3. So I'm looking for where tangent square root of 3. It is square root of 3 right here. And it is square root of 3 right here. Can someone tell me which one of those answers is the correct one? You have a 50-50 shot. It's pi over 3 or 4 pi over 3. Nick?
Pi over 3.
Why is it pi over 3?
Because it has to be in quadrant 1 or 4.
Yep, correct. So the answer is pi over 3. One more back. Pi over 3. Can someone tell me the arctangent of 1? Without me walking through it, can someone give me the arctangent of 1? 1?
Pi over 4.
Pi over 4. Yes. Absolutely. Pi over 4. And that's it. Not so bad, right? With tan inverse. As long as you have the values written down. If you didn't have the values written down, now you're struggling to divide a whole bunch of stuff.
Why is it pi over 4?
Tangent value as 1 at pi over 4. Good? What did you think it was?
I didn't know at all.
Oh, okay. Do you have your tangent values written down?
Yes.
Oh, okay.
I just didn't realize.
Oh, yeah. We just got to find our tangent value. Tangent's 1 here, so the answer is pi over 4. Does that make sense?
Yeah.
Okay. So I'm very angry about it, though. All right, inverse of cotangent function. This is the hardest of the inverses. Not graphing, just understanding what's going to happen down here. And I'll tell you a trick to overcome thinking about this. All right, cotangent. Cotangent has vertical asymptotes at 0 and at pi. And cotangents, I was sloping down, so it looks something like this. Well, that's quadrant 1 and quadrant 2. So tangent inverse is in quadrant 1 and quadrant 2, so quadrant 3. Oh, cotangent, yes. Yep. Cotangent, thank you. Cotangent inverse is in quadrant 1 and quadrant 2. That's going to cause us problems in a second, but we'll put a pin in that for a second. We're going to graph it. To graph it, wherever I have a vertical asymptote, the inverse is going to have a horizontal asymptote. So we have a vertical asymptote at 0 going across the y-axis. So we're going to have a horizontal asymptote going across the x-axis. So y becomes x. And we also have a vertical asymptote at pi, so we're going to have a horizontal asymptote at pi on our inverse. Now if you can kind of picture this getting flopped like this, so it sticks like this, it gets flopped like this, it's going to go down as well. So because cotangent goes down, cotangent inverse, this is a terrible way, I was like drawing it this way. This is my cotangent inverse. And we are in quadrant 1 and 2, so I'm going to fill that in that little blank there, 1 and 2. There's a giant problem up there. There is a huge, huge problem. Nothing's wrong. I wrote everything correct, so don't look for a mistake. The big problem is let's look back at secant. So secant had the exact same domain. So secant inverse had the exact same domain as cosine inverse. Bless you. So when I went through cosine, to get my answer, I didn't care what quadrant I was in because they shared the exact same quadrants. Secant inverse and cosine inverse had the exact same domain. Tan inverse is here. Cotangent is here. They do not share exactly the same domain. However, we still have to go through tangent inverse to get our cotangent values. What this is going to mean to us? What this is going to mean to us is we have to know these 3 things. All right, I'll show you a shortcut because sometimes memorizing this stuff isn't that easy. So let's just see an example of this. All right, cotangent inverse is -1 over square root of 3. It is a negative value, so if x is less than 0, we have to use this middle one, that tan inverse of 1 over x plus pi, and we'll look at why we have to add pi to it. All right, let's just set it up like it says up there. So I'm going to set this up as tan inverse of 1 over x. X was -1 over square root of 3. And then we're going to add pi to it. So simplifying that, we'll have tan inverse of negative square root of 3 plus pi. Here's where that plus pi comes in. So let's go ahead and find the tan inverse of negative square root of 3. Yes? Oh, you're giving? Okay, what is the tan inverse?
Is it like negative pi over 3?
Negative, yeah. So we look here, because tan only exists over here. Tan inverse only exists here. So I'd be looking at 5 pi over 3, or in other words, negative pi over 3. All right, either one works. Does cotangent inverse exist down here? Does cotangent inverse exist down here? So we have to add or subtract pi to bring it back up into quadrant 2. Because tan inverse lives in quadrant 4, but cotangent inverse doesn't. So we have to add or subtract pi to it to bring it back up here. All right? So I'm going to use your value, and that was tan inverse of negative square root of 3 equals negative pi over 3. But then we have to add pi to it. Pi is really 3 pi over 3, so this is going to be 2 pi over 3. Nick, you okay? Because you need to know this. Who finds that really ridiculously complicated? And something I'm probably not going to memorize on a test. All right, who wants to know a cheat on how we can do this? All right, let's cheat the next one. Let's cheat the next one. I'm going to change the next one's problem. All right? Because square root of 3 isn't that interesting. It's just it's just a normal one. Let's go ahead and do arc cotangent of -1. We're going to do arc cotangent of -1. We're going to shortcut this one. We're going to shortcut this one in the fact that cotangent exists in quadrant 1, in quadrant 2, right? So we know we're going to go through, let me real quick. We know we're going to write this as arc tangent of -1 over 1. And let's forget about the adding pi or subtracting pi thing. Let's just realize that cotangent exists in quadrant 1 and 2. And we are now going to find where tangent inverse would equal -1 if it happened to exist in quadrant 2. All right? So I'm just going to figure out where tangent equals -1. And that is at 3 pi over 4. Our answer is just going to be 3 pi over 4. All right, for me that's a lot easier than finding -1 where cotangent exists, adding pi to it, and then getting back here. All right, so what I do is I just pretend that tan inverse exists here, and I find what value would be if it existed, and that would be 3 pi over 4. So I jump right to the answer. I jump right to the answer that if tan inverse existed here, the tan inverse of -1 would be 3 pi over 4. So that would just be 3 pi even though technically it's an incorrect method, it saves us the time of having to add and move our finger and do weird stuff like that. All right. Is that an easier way to do it? Yeah? No? Did I make it more confusing? Same amount of confusing? Nick, your head's not down this time, so maybe it's better.
I think it makes sense the other way because it's just like 180 degrees.
Oh, good. Then use that method. By all means, use this method where you just find out that tan inverse is down here, 180 degrees, gets us our answer here.
Be on the same line.
Yep. This can be on the same line. It's just one method. You don't have to think about the negative or adding or something. It just gets you right to the answer. Just know where cotangent inverse lives and make sure you pick an angle that is there. All right. Do not pick one down here just because the tan inverse is down here. All right. All right. Questions, comments, concerns? All right. Then just the recap. Just a quick recap. Remember to write out cosine for our inverses. That will give you the inverses of cosine and sine. And it also gives you the values for, or the domains for secant and cosecant. I should put my negatives there. Inverse. Inverse. All right. With cotangent, we just have to write cotangent. And that gets us our domains of our cotangent and our tangent inverses. So we really just got to remember cosine and cotangent. And if I was going to take a test on this, that might be the first thing I'd write down when I get two inverses, right? It's real quick. Draw a T and draw, cosine and cotangent, and then you'll know which possible angles are your solutions. All right? Any questions? All right, let's go ahead and get started on our homework. We do have about 5 minutes Oh, I did want to talk about, look at those last, I think it's 6 questions. Look at the last 6 questions on the homework. Those are embedded trig. So do what's in the parenthesis first, get a value, and then so it might say like the cosine of sine inverse of some number. So you'll take the sine inverse first, get that answer, and then take the cosine of that value. Alright? Don't overthink those. It's just do what's in the parenthesis first, simplify that to a number, and then do the outside one next.